Okay, brilliant. Well, let's get started. So welcome to our next panel at the post-COVID conference, where we're going to be delving into the world of AI and big data. I'm Mark Purdy. I lead a company focused on economics and technology research, really looking at the intersection of those trends, with a particular focus on AI and machine learning. Now, the specific question we want to address today is, how can AI and big data empower people and businesses in the post-COVID era? Or more precisely, when does it empower people and when does it potentially disempower people? We hope to sort of disentangle some of those issues. So we have a stellar panel of speakers lined up. A couple of them may be a little bit late, but hopefully they will be joining us shortly. But what we hope to do is make this quite an interactive session, and hopefully we can get lots of questions from the audience. So I want to begin by just asking everyone in our virtual audience to imagine a couple of different scenarios. So the first scenario is you go for a job interview and you're positioned in front of a computer screen, you're asked a series of questions, and then an algorithm determines your emotional fit for the role in question. So that's one scenario. Second scenario, you're given an AI-powered digital assistant which can process data, it can conduct some client meetings, it can provide advice. You know, sounds perfect. Third scenario, you've got an insurance company that's using drone-based images of households in your neighborhood to offer discounts on insurance to some households, but not to others. And then fourth scenario, a healthcare provider uses an algorithm to screen tissue samples for cancer, for early signs of cancer, and then determines who should get treatment. Now, I mention these scenarios. I mean, there are actually hundreds, if not thousands, more kind of examples of, you know, how we're seeing AI being used to make decisions. But I mention these examples specifically because, depending on the context and your own situation, these could be seen as massively empowering or equally, you know, disempowering to individuals. And this is the reality of what we're moving to in this age of artificial intelligence and machine learning, because we're actually entering a world where many decisions affecting our lives, you know, whether it's education, health, our life chances, are being determined by machines, by forms of machine learning. And this raises some fundamental questions. You know, how do we square some of the benefits, the real undoubted benefits of AI, you know, personalization, increased productivity, against some of the downsides, you know, the potential for new kinds of biases, new exclusions, new inequalities. But I think even more fundamentally, how do we know when we're being empowered and when we're potentially sort of being manipulated or deceived? I mean, because the nature of many machine learning algorithms is that they're not necessarily transparent, that they, you know, are a black box. So there are some fundamental questions that are being raised here. And ultimately, what we're trying to understand is, how do we get greater trust in AI systems? You know, a lot of businesses, a lot of technology companies talk about responsible AI, but what does that really mean when we begin to, you know, scratch the surface and to see what's really happening? And ultimately, what kind of interventions do we need in order to make AI, to get more of the kind of the magic, if you like, of AI rather than the menace? So, you know, these are some of the questions that we're hoping to explore today. We have a really great panel of speakers. I will introduce the two speakers that we have at the moment. First up, we've got Anand Rao. Dr. Rao is a partner and a global AI lead at PwC. He's a partner in PwC's advisory practice. He's co-sponsor for the AI Center of Enablement within PwC, and he's got over 35 years of experience advising C-level executives on digital strategy and responsible AI across a whole range of industries. And he's edited 4 books, published many papers on AI in referee journals and conferences. And so we'll come to Anand shortly. And then our second speaker is Sinan Kayhan Aral, who's the David Austin Professor of Management at MIT. Sinan is a global authority on business analytics. He's an award-winning researcher, entrepreneur, venture capitalist. He's director of the MIT initiative on the digital economy, which many of you are probably familiar with. He's also a founding partner at Manifest Capital. And then we do have 2 other panelists, and we'll sort of come to them as soon as they are able to join us. So the format for today's session, we're going to hear some opening statements, presentations from our speakers. We'll then have a series of follow-up questions, and then we'll open it up to the audience. But please be thinking of the questions you would like to ask, put them in the chat box, and then we'll sort of queue those up to put to our panelists. So if I can begin, I will ask Anand if you can take the floor and give us your views on AI and its potential, impact to empower or disempower people. Thank you.
Thank you, Mark. Yeah, feel free to interrupt me. I'll probably go for 10 minutes or whatever time. Yeah, if going over, feel free to stop me. Let me just share a quick presentation here. Can you see the presentation?
Yes, I can. Yeah.
Okay, let me just get it on full share mode. Yeah, so I wanted to talk a little bit around how we can leverage AI and big data to empower people and businesses, so the topic of this conversation. And I wanted to approach it, given that this is a sort of a post-COVID summit, I wanted to see specifically over the past 2 years what has happened within the broader society, and how we can take some learnings from that to empower people and businesses. And Mark, I think some of the questions that you posed are beyond the pandemic, right? So whether we had the pandemic or not, those are all very relevant questions on to what extent AI is making or should make decisions of key importance in our lives, whether they are health decisions, financial decisions, psychological, emotional decisions, whatever they are, how they should make. So I'll come back to that, but I wanted to basically start with very much a COVID view around what has been happening, especially in the AI side, AI and big data side, and then draw some lessons from that. So key learnings from the AI and COVID-19, AI and big data and COVID-19, and then some recommendations for moving forward as to what are some of the learnings and what can we do about it. And after that, I'll just address a couple of points to just address your 4 scenarios that you laid out. Now, just a sort of a quick rewind, right? So March 2020, so everyone is sitting, and then March 10th, I think, is when the World Health Organization declared it to be a pandemic, right? So the famous announcement. Now, obviously, huge amount of activity after that. So since then, some of the work had been going on, right? So epidemiological work has always been around. People have been working, but it sort of brought everything to limelight. So what you're seeing here is what happened just literally just within our firm, and how we started helping our clients during the pandemic, especially the early days of the pandemic. I'll go through a little bit, and it's not just about what we did. In fact, it's sort of multiply that almost, I would say, 10,000 fold. And that's what has been happening in the academia, in the industry, in the policy-making group, and all of that, right? So now, so what exactly happened? Now, if you actually look at it from an AI perspective, we have moved a long way pre-pandemic versus now. So just give you an example of the kinds of things that we and others have been doing. On the left-hand side, you're saying essentially models that are being built. I'll come back to what models in a minute, but models that are multi-layered. Obviously, the pandemic was impacting the global level, so every country had its model. So by now, the one that you see on the temporal layer, right? So the curves, or the shift the curves was the mantra that everyone was using. That's very familiar to everyone. Every common person on the street can recognize the curves and the multiple bumps in the curve. And so we started building models at a country level, state level in US, even at a county zip code level, not only building it at that local, but also looking at it in a time-based manner, temporal, right? So what's happening today, what's going to happen in a week's time, in a month's time? Again, no one knew exactly when and how the wave would go, but we were still projecting based on various things. Now, you see multiple layers there, right? So individual layer, individual people, their risk propensity for COVID, household level, school level, right? So workplace level, national level, all kinds of interventions. Everything was sort of being modeled. We'll come back to the modeling, but that's what is happening. And what's interesting about it is there's one problem that the whole world was trying to tackle, at least in the months of March, April, before we started sort of relaxing, and not fully relaxing, but at least starting to look at a broader picture. Now, in each of these, we were looking at very specific behaviors, right? So at the bottommost point, you'll see the core modeling of COVID-19, right? So epidemiologists do these models day in, day out, but now that became common vernacular: susceptible, infected, and again, given the COVID-19, asymptomatic, symptomatic, hospitalized, severe, recovered, dead, right? So the process that everyone goes through, right? So hopefully not to the end, but hopefully in the recovery stage. So that's the disease modeling. Then from there, we started looking at behavioral modeling. So what about people wearing masks, people doing mobility? Are they moving around, right? So are they maintaining distance, and so on? And the governments and the public health bodies started looking at closures, school closures, bar closures, whole host of different behaviors. Take that on the next stage into the economic side. So what is its impact on unemployment? Bankruptcy, stock market, sort of impact of stimulus, right? So on the overall economy. So from the disease to the behaviors of the people, the governments, the community, the schools, we started moving into the economic situation, what was happening. And I show the curves there. Everything was still centered around the pandemic, right? So the V curve, the U curve, W curve, right? So economists were talking about it. And when will the recovery happen? What was the impact? What is the impact of the stimulus? Very much macroeconomic, all tied back to this, right? So every analyst firm was doing that. And not only the multi-layered behavioral economic, but then it was also very sector-based. So we were, March 10th is when the pandemic was announced. By March 26th, we had a tool that we were making available for all hospitals to really check in their locality how many patients are likely to be there, how many are going to be hospitalized, what kinds of ventilators do they need, ICUs, and so on, right? So a whole host of different things on the provider side, the payer, pharmaceutical. I won't go into the details, but every sector started looking at the pandemic, the behavior, the economic implications for each of their sectors. From the sector, they went into the company, right? So the reason I'm building up all of this is that's how the data analytics AI was being used by a large number of companies, academics, policymakers. All of them were working around various things, right? So again, a list of things. So very active way, and probably a very much a focal point like none before, where everyone around the global community was addressing, quote unquote, one problem, one issue, or the implications of this one issue. Now, a number of good things came about from that. So again, I'm focusing myself on just AI and big data. The good things were, again, I've highlighted some of the news articles on the right and the key aspects on the left. Speed, scale, right? So the speed of decision making was phenomenal, right? So we had to do things, right? So people were dying, literally people were dying on the street, if you like, and we have to make decisions. With or without data science, we have to make decisions. So that essentially forced the AI people, the analytics and the AI, to start coming up, start finding not the best solution, but reasonable solutions. Rather than just using a gut feel, what is the best I can do in the next 24 hours versus the next 7 days versus the next 14 days and so on. And some of the early days, there was very little data, right? So there were a number of assumptions, but very little data. And this is where I know a number of people talk about machine learning, deep learning, data-driven learning is where we have been so caught up in before the pandemic. And what was nice to see is this model-based AI. So people understanding what are some of those implications from an assumption perspective, and then running scenario models, simulation models, sort of tackling some of the uncertainty with all of the different scenarios. We saw increased adoption of AI, right? So other interesting in the enterprises, interesting collaboration for the first time, a very focused collaboration between academic community, the business, the government, or the international bodies, right? So all working together on similar problems. And what was phenomenal to see also was the sharing, right? So literally within a couple of weeks, everyone started making the data available. And not only the data about what was happening with the patients and the community as such, but people started making the data around the disease and the COVID-19 virus itself available to everyone, right? So the sequencing was sort of public domain. Researchers across the globe were using that and doing the sequencing. So images of lungs, right? So all of those things were happening at a large level. And I would say some limited sharing of COVID-19 models, but not necessarily. We'll come back to that point, right? So you see speed, scale, sharing, all happening at a global level to some extent, right? So this is what we were seeing happen during the pandemic, at least the early years of the pandemic. It's not all great news, right? So I want to temper this with, yes, it was a very significant global issue and everyone dropped everything else that they were doing. And this was the important thing for pretty much the whole world. Now, there are some bad things as well, right? So it's not all good and rosy. Now, in the hurry, in the speed at which we were doing things, we were not that careful. And one of the things was sort of model bias, right? So impacting health, treatment, financial well-being, a number of examples of bias in the algorithms, right? So from vaccine provisioning to looking at the scanned images, number of areas where people of color, people of the gender, right? So all not quite being addressed. And in some cases, the citizen surveillance, so back to the responsible AI issues, right? So bias and fairness was the first one. Second one was more around security and privacy of people, right? So citizen surveillance using contact tracing. Again, people were willing to do that to some extent, but not everyone, right? And then the potential misuse of that for other purposes other than just tracking the disease. And what's also interesting is, even though the number of models that were developed, it's somewhat sad to see that, again, given the pressure of the timing, the models were not calibrated, not validated. And so much so that there is this organization called COVID-19 Precise, which basically is doing the validation of these models. And literally, they couldn't find any model that can be put into full practice. So you can see the statement there in MBJ, where the people didn't have the right procedures, people were going fast, publishing, which is all good, but there's no academic peer review and rigorous review, reproducibility of things, which I think as we move into the next stage, those are some of the critical things that we need to get to as a community. And the international collaboration, even though it started off well, and there have been a number of cases where that has actually gone down. You see article in Nature, which actually shows that after a couple of months, the collaboration actually started dropping with number of accusations on different groups and what they were doing with COVID, right? So again, it's not as rosy as everyone was sort of collaborating. There was international collaboration actually in some cases actually went down. So I want to sort of stop here with the final set of recommendations. I can look at a little bit around responsible AI after that. So I think there are 4 main things that need to happen, and some of them are already happening to some extent, but also it needs to be done with various stakeholders here. So on the left-hand side, we did see a number of groups with the open data. The governments were coming up with the data, and even private companies were hosting various kinds of data sets on their cloud platforms. And the open data is fine, but I think we also need to validate those data sets. So the health, economic, behavioral data coming in the authenticity and of those data, the reliability, quality of that data becomes important, whether it's public versus private, making sure that the privacy of that data is maintained. When we take open data, it's not just dumping everything into open data. Is there a way in which governments, academics, associations, business all can come together, not only have the data open, especially in the health and the macroeconomic areas where it's sort of less competitive, if you like, but also make sure that the data can be trusted. So it's not just open data, but it's open, trusted data, open, high quality data. So the second aspect that I think we as a community should focus on, we've all seen over the past 20, 30 years, the movement towards open source software. Now, open source software is fine, but software and the models are one level of abstraction higher. There are epidemiological models, but there are literally hundreds of epidemiological models now. And what we really need to get to is, just as we have open source tools and open source software where one person builds on top of the other, we need models also to be modularly designed and open in a repository so people can start building off each other's models. Everyone doesn't have to go and build the same epidemiological model or make mistakes while building those models. So those things should be available for others to start tapping into. Similarly, economic models should be built by a group, again, not suggesting that one group built it, but a curated set of economic models, reference models as I'm calling them, that others can use, that governments can use, businesses, academics can use. So we really need to have this notion around open models, open reference models that are plug and play, right? So still a long way from there, but that's something that can really propel us in the AI data world. And I would sort of focus on health, which obviously we need it for everyone. It is sort of less contentious in terms of private sector competition. And the other area is sustainability, is again where we could build climate change models, which are more interchangeable, modular, and so on. And the third one is open compute. What I mean by that is to run some of these simulations literally takes multiple days or hours. For example, when we were running our COVID-19 model, we were running it by zip code just for one state. It took 12 hours to run through the entire model based on the previous year's data, previous day's data around hospitalizations, death, and so on, right? So for Texas, it took 12 hours to run, right? So you need compute power, right? And the compute power is still very concentrated in a couple of companies, couple of areas. So how do we make some of the compute available for these types of models, sort of publicly valuable models, global models, if you like, or global data? How do you make that compute available? And last but not least is making sure that it is governed properly. It's not a free-for-all, dump your data or code or models. how can we make sure that the academics and some of the associations get involved in making sure that they're reproducible models, their models are fair, robust, validate some of these, like the COVID Precise is now going about validating every model and then sort of giving the parameters, telling what is missing from those so that people have a chance to update those models. And as a community, we start using them rather than just having all of these models, having them usable, just as we have in the open source community. There are very specific open source tools that everyone uses. Any updates get done to that open source, like scikit-learn, for example. And then it's the coming together of the academic, professional, business, government, all process, right? So it's not just a private sector alone would do it or a public sector alone would do it. It's a combination of those two with some of the civic engagement organizations and the academic world coming together, right? So this is sort of a collaboration between government, business, academia, and associations that need to come together to really look at responsible AI. And the responsible AI is not just the AI or the models as I lay out here, it's also the data, the compute, and the governance that goes with it. So maybe I can stop here. I mean, I do have a few slides around the responsible AI. And let me just point to one slide here, and then in the discussions, I can go more into detail. When we talk about responsible AI, we think about these entities here. So on the left-hand side, you see what we call a strategic. So there are a number of organizations, more than 180 or 190 organizations, associations, and governments that have published AI ethics or AI ethical principles, so data ethics. So all of those things are the basis in which we operate. So most of them are at the policy level. Of course, EU has an AI Act regulation that's currently under consideration, and we'll see more of those in various jurisdictions. So you have the policy side coming from the left, but that's at a very high level. If you go into a company, it's not tangible enough for them to practice some of the principles. There's no disagreement largely with all organizations to say my model should be fair and unbiased. So no one would query that or question that. But how do I do it, right? So if I'm a data scientist, what do you want me to do? I've got this underwriting model, as you were just explaining there, Mark, right? So I've got this model or an employment model. What do you want me to do? What don't you want me to do, right? So we need very specific things. And one of the things that we talk about here, there are 30 plus definitions of fairness. It's not that the AI algorithm is unfair in some sense. It's just that our definitions of fairness is very different, right? So my definition of fairness is very different to your definition, and that too might differ by the task at hand or the decision at hand, right? So how do we handle those things, right? So who makes that decision as to which metric I should use for fairness? So that's where we get into the nitty-gritty of how do you make these things into practice. Explainability, interpretability of models, right? So how do you do a trade-off between accuracy and explainability of a model? You're building an underwriting model, and a decision tree algorithm, let's say, gives you 90% accuracy. You build a deep learning model, it is 93% accurate. So does the 3% of accuracy warrant building a deep learning model, which may not be as explainable as a decision tree model? Then that's a business decision we have to make. So how do you make those trade-offs? So on and on. So you can look at the privacy, security, all of those issues are very technical issues where we need to translate the principles that the community at large has laid out so that we can bring it down to the very specific use cases, as you were talking about, whether it is underwriting use case or a use case around employment. We need to say, at what point do I value my privacy that I don't want the system to know my data? To what extent is it anonymized? And also to what extent can it be de-anonymized by bringing in other data, right? So there's a lot of work that's gone in there. I think we need to understand those parameters. And at the right-hand side, this cannot be solved purely from a technology perspective. So some of the tech vendors would have you believe that there is some software somewhere and a very sophisticated AI that can check on other AI and then give you the right answer. Unfortunately, nothing like that exists, right? So you really need people. It's a socio-technical system. You need people to be governing. You need people to be looking at the risk and deciding, do we want AI to be doing my interviews or not, right? So that's a people level decisions. Then we can then decide how good the AI is, and based on that decide whether I really wanted to operate in screening my candidates or not, right? So same thing with compliance and governance. It's very much a people-related issue as to how do we govern some of these models. In spite of all of the things, how do we escalate it and how do we take responsibility? So this is the way we think about responsible AI. And then we can address the different use cases that you had along these spectrums and say, where and how do we really want AI to basically do this? That let me stop here, and I've taken 15 minutes.
Right. Thanks very much, Anand. That's a fantastic overview. It did strike quite a lot of questions, which we can sort of follow up. But I think now I'll turn to Sinan, and I should have mentioned Sinan actually has to leave a little bit early, so we'll try and get his sort of questions in before the end. So Sinan, over to you.
Thanks, and Anand, thank you for that. That was very illuminating and really tracks with our experience at MIT in terms of what we saw during COVID. Let me start. I'll just give you guys some, I don't have any slides, but I'll just give you a little bit of an overview of how we at the Initiative on the Digital Economy at MIT experienced the role of algorithms, models, and data in responding to the COVID pandemic, maybe drill into that academic experience of data science, big data, and machine learning to address COVID from the perspective of our team at MIT, and then zoom back out to talk about opportunities and risks and a path forward for dealing with AI from a broad level. So when the pandemic hit, so the MIT Initiative on the Digital Economy is the largest research consortium at the business school at MIT, the Sloan School of Management. We do peer-reviewed research on a number of different topics related to the digital economy, from misinformation to human AI connection, to digital marketplaces and digital labor markets, to the rise of digital social networks, how that's affecting news consumption and opinion and decision making and so on, as well as a track on AI for good and global AI governance. And so we've been doing this kind of research and publishing in Science and Nature and Proceedings of the National Academy of Sciences for many years. And we have tried our best to address what we see as the top challenges in AI, but also in the use of data and global governance of data and things like that. We work a lot with private companies with whom we collaborate to collect data, but also to address questions of an applied nature that are really relevant to the management of organizations, but also to global institutions like the World Health Organization, the CDC, and I'll describe some of those collaborations. So when COVID hit, as director of the IDE, I called an all hands meeting and I said, we have to point all of our intellectual capacity directly at what is clearly the most important topic on the planet today. We had a bunch of other projects that we were working on, things that were important. We put most of that on hold, and the entire team sort of dropped everything and started to focus on COVID. So we spun up several different projects, and let me just describe those a little bit, because they really do get exactly at what Anand was talking about with regard to the use of AI, machine learning, and big data to empower global solutions to what was then the most acute crisis on the planet. So we immediately spun up a project in which we worked with Facebook and SafeGraph to collect data on 30 million cell phones in the United States and their mobility, how they were moving in response to lockdown and stay-at-home, shelter-at-home orders. And what we were able to do with that data was to estimate the effectiveness of various state, local, county, and national policies in terms of affecting the mobility of citizens in the United States, and then to estimate what that did to the trajectory of the pandemic itself. We combine that with data on 220 million people on Facebook in the United States to understand the flow of information across the country. As somebody was experiencing a lockdown in New York, were they communicating it to people in Florida or California about their experience? And how did those communications change the behavior of those people in Florida and California and all across the rest of the United States? And we found some extremely important and interesting results. I can categorize them as sort of two areas. The first is we were able to estimate econometrically the effectiveness of state and local and national policies on reducing the mobility of people and reducing the trajectory of the pandemic. And what we did with that data and that paper was we advised the National Governors Association, which is the association of all 50 governors of 50 states in the United States, about their COVID policies, their shelter-in-place policies, their mandates of various kinds that changed over the course of the pandemic. The second thing that we did was we estimated what the hyperconnectivity that's been created across the globe in the last 20 or 30 years with the advent of Facebook and WhatsApp and TikTok and Twitter and so on, what that connectivity, that hyperconnectivity did to the flow of social and economic behaviors from one municipality to another. So I'll give you a perfect example. What we found, and we're very clear from the data, is that a lockdown in New York did not just affect the mobility of citizens in New York. It had direct causal effects on the mobility of citizens in faraway states like California and Florida, because all of these people were forced to shelter in place, were off the streets, in their homes, on their devices, and talking to their friends and relatives in different locations about staying at home, about sheltering in place, and so on. And where we saw tremendous connectivity, we saw tremendous behavioral spillovers. So in other words, there's a lot of connectivity over Facebook, for example, from New York to Florida, because a lot of people who live in New York, their parents live in Florida. And so even though Florida didn't institute a lockdown order as soon as New York did, when New York instituted its lockdown order, people in Florida stopped moving because they were talking to people in New York and learning the severity of the crisis, learning the importance of staying home, and that New York was in lockdown, and so on and so forth. And so what that meant was that an isolated piecemeal response to the pandemic was not going to be effective because behaviors spill over. We also estimated the geographic spillovers of behaviors when a state locked down. What we found was that people fled the state to find services and goods in states adjacent that were not locked down. So for example, when the states around Georgia locked down, people flooded into Georgia to get haircuts and to go to the mall. And in fact, we estimated that over a 1 month period, there was, or actually I should say over I think it was a 2 week period, something like 500,000 travelers flooded into Georgia because Georgia was not on lockdown and you could get a haircut and you could go to the mall and go shopping. Whereas neighboring states like South Carolina and Tennessee and so on had lockdown. So what the behavioral spillovers and the geographic travel spillovers implied was that we needed a coordinated national policy. in order to control COVID, because COVID doesn't respect boundaries of states and localities and policy. Its trajectory is affected by behavioral spillovers and travel spillovers from state to state. What that meant was the National Governors Association and the governors of 50 states would have to coordinate with each other their COVID policies to be effective. And what we did was we gave a coordination map to each of the 50 governors and said, these are the states that influence your citizens the most, that are not your states. In other words, when these 5 states change their COVID policies, your citizens change their behavior the most, you need to be in close contact with these other 5 governors. And we did that for every state, and we did that and we estimated the influence of all 49 other states on every one of the 50 states. We also, in collaboration with Facebook and the World Health Organization, spun up the largest longitudinal survey on COVID behaviors, norms, and perceptions in the world. We surveyed nearly 20 million people about their perceptions and behaviors around masking and staying at home, and whether they would go to work, and whether they would take a risk to eat out, and their opinions on vaccinations and so on. And surveying 17 million people, again, big data, we were able to inject randomized experiments into the survey where we randomized what people saw and estimated how that would change their behavior. So for example, we randomized the provision of giving people information about other people's opinions about vaccinations from their local area. How many people in your local community say they would take a vaccine? And we randomized whether they saw that information before or after they were asked whether they would take a vaccine. And we estimated that showing people truthful information about the large and growing majorities of people that say they will be vaccinated increased the rate that people say they would be vaccinated by about 5% on average. And for people who were hesitant or didn't know, it increased that rate by close to 8%. Now, at the time, Jen Psaki, who's the White House press secretary here in the United States, was answering questions about COVID during press conferences by saying, we're very worried about vaccine hesitancy. We're worried that people aren't getting their vaccine. When we published these results, the White House reached out to us, and we began coordinating and advising the White House on White House policy with regard to vaccines. And shortly after we advised them, Jen Psaki completely changed her press secretary responses to those questions. And instead of saying, we're very worried that 8% of people aren't returning for their second dose, she started saying, we're very pleased that 92% of people are returning for their second dose. And she followed that with a statement that said, and we believe the vast and growing majority of people are seeing that vaccines are important and that taking a vaccine is helpful to protect yourself and your families and so on. And we believe that this had meaningful effects on the rates of vaccinations in the United States. We made that to the open data comment that Anand made. We made all of that data publicly available, and numerous other institutions, including the World Health Organization, Johns Hopkins University, and many others, started using that data to model things like, what are the strategic policies around which types of institutions should be opened first to balance the economic hardship of closure and the health risks of not closing things like restaurants or transportation facilities and so on. And we published those papers in PNAS and made all of those data available as well. So that's a really good sort of set of examples around how we responded to the pandemic using machine learning, large-scale data science, to advise the National Governors Association, the various governors, and the White House about how to address the pandemic. So if I could zoom out for about 3 or 4 minutes I think there are several opportunities with regard to AI and big data, not just with regard to COVID, but generally speaking, several challenges and I think several really important things that we need to consider as we pay the path forward. The first sort of impact and opportunity is the vast hyperconnectivity that these digital systems have created on the planet. So over the last 15 years, the rise of digital social networks and the data-based algorithms that run them have completely rewired the central nervous system of humanity. We get most of our news from these social networks today. We get lots of our decision-making criteria, the information, but also the opinions of others that influence who we vote for, what products we buy, whether we get vaccinated, and so on, are being influenced by news that is ebbing and flowing on Facebook, being shared from person to person. And algorithms determine which of those news get highlighted and spotlighted more, and which of them get demoted. We've also seen tremendous advances in health-related AI. So the use of machine learning, for example, to read radiology, to be able to quickly identify, cancer in various X-ray or MRI results. And this doesn't mean taking the doctor human out of the loop, but triaging the likely cases and the unlikely cases, and then allowing the doctors to focus on the areas that are most difficult for a machine to be able to understand. I think labor markets are being dramatically affected in terms of finding work, in terms of interviewing, in terms of standardizing the interview process through automated analysis of technical interview questions and so on. And I believe that the explosion of data is a big part of this. When it comes to health, it's also about enabling doctors to promote telehealth, right? When it comes to labor markets, it's about the rise of remote work, and we're seeing that stick post-pandemic. How are we going to grapple with and cope with that? When it comes to challenges, Anand mentioned several of them, and I'd like to just highlight some. Bias is clearly one. We've seen over and over again bias against ethnic minorities, bias against women, not because the algorithms are coded with that bias, but because they are trained on data that reflects that bias. And that data source, those data sources that train the machine learning, contribute to the bias that the algorithms then display in the recommendations that they make. And that's something we have to get our hands around. Another one, important one, polarization and extremism. And this isn't just algorithms, this is algorithms combined with business models. When a business model favors engagement, and engaging things are mostly anger-inducing, blood-boiling, or surprising, shocking, novel, then those algorithms are going to favor things that lead to outrage or contribute to your confirmation bias or deliver to you more and more extreme content, as the old extreme content is not enough to stimulate the dopamine that you once needed with the old content. A third really important challenge is misinformation. We did a very large study, which we published on the cover of Science in 2018, where we examined all of the verified true and false news that ever spread on Twitter from 2006, Twitter's founding, to 2017, 10 years of data. We collaborated directly with Twitter to get access to the entire Twitter historical archive. And what we found was that false news traveled farther, faster, deeper, and more broadly than the truth in every category of information that we studied. This affects vaccination rates, health misinformation, it affects democracy, it affects our economy with the rise and fall of stocks Meme stocks, we saw this with GameStop and AMC, that these types of social media are really affecting equity markets, health outcomes, vaccination rates, and voting, democracy, and political inclusion. Finally, mental health. Obviously, there are big questions about what this is doing to our kids, how these algorithms are promoting, for instance, false body image, and what that does to anxiety and so on. And let me just highlight, there are a plethora of things that we really need to do, but I'll just highlight three. I think the most important one is transparency. We don't know enough about the private algorithms and how they are making decisions in order to decide whether the way that they're being programmed is safe or is combating bias, it is leading to extremism or polarization. We need a lot more transparency. And that's why we have people like Frances Haugen, who is the Facebook whistleblower, trying to release tens and thousands of documents from inside companies because there's a fundamental lack of transparency. Second is we need to focus on safety and accountability. We need to be able to have private organizations make themselves accountable. We need to be able to have governance and rulemaking that focuses on the safety of outcomes with regard to data and algorithms. And finally, something that is really important is we need competition and access. The reason for that is when there is market concentration, the incentives to change are very little because a monopolist makes money hand over fist. When there's competition, real competition, and real access to data and data processing power, that allows competitors to give choice to the consumer. When the consumer has choice, innovation goes up, safety and accountability goes up, because consumers can vote with their feet towards platforms that are not inundating them with harmful outcomes. So I'll just stop there. Thanks.
Sinan, thanks so much. That's absolutely fascinating, and so many issues for us to kind of explore there. I guess I'd like to start by maybe looking at some of the issues around data and access to data, because I think what you both have said in a way is that access to data and the right kind of data is absolutely critical to making sure that we can really harness the benefits of big data and AI. But how do we actually do that in practice? Because clearly there are some problems. I mean, a lot of data is hidden. It actually costs money to sort of generate useful data, even for organizations to find the data that they have. And of course, you can argue that there are commercial incentives against sharing data, because the platforms, the social media platforms, of course, they see their data as being incredibly valuable, so they don't necessarily always want to share it. So can I push both of you a little bit to kind of say, well, how can we actually, untap those sources of data? What are the mechanisms? There's been talk about data trusts and different sort of regulatory and legal means, but do you see a way of actually just increasing that access to more and better quality data?
I'll just take a quick stab at that, and I'll try to be very brief. I think there's really two avenues. One is sort of a regulatory approach, and another is sort of an innovation commercial approach. So in terms of a regulatory approach, you can imagine, and we see the EU moving towards this already, and I think that we need more of this. Regulation that addresses competition. I think the most effective form of regulation that addresses competition, and I'll take the court system and bringing antitrust cases out of this for a minute. Laws that can be passed are things like the Access Act that's sitting in front of the U.S. Congress now. which requires interoperability amongst platforms with greater than 100 million users. This does two things. It forces the platforms to take down their walled gardens, which in economies that run on network effects, where the value of a platform is a function of the number of users that it has, when those platforms become interoperable, users can switch between platforms and still message their friends on the other platforms. Now, as part of this type of act, an access act that would require large companies with data on individuals and social networks that are messaging between them, say Facebook and Google and LinkedIn and TikTok and so on, all of those would apply here. You have to mandate access to certain pieces of data across companies to enable that interoperability, sharing a standard set of data and protocols that enable that kind of interoperability. Then we would have standardized understanding across multiple points of failure for a certain set of data about individuals, and that would be accessible to all and verifiable by all. That would create innovation and competition and build in safety around that data. When it comes to commercial innovative approaches, there is a movement towards enabling more user control over their own data. So, for example, Tim Berners-Lee, the inventor of the World Wide Web, is working on a startup now that would generate more control, user control over their own data, and to give access to that data to private organizations for some benefit, and that the software that he is developing would give the technical means by which those users would be able to control their various data and give it out to different types of companies. And in addition, we need a culture change around all of that. Regulation and innovation needs to be intertwined with a different mindset with regard to openness of data, with regard to user centricity of data, and so on.
Thank you. Anand?
Yeah, no, very much agree with what Sinan was saying there, right? So the approach from the regulatory side and the innovation side. Now, the way we look at this issue is, I think there's a range of things that you can do. At one end, it is the regulation, but companies can do, right? So from self-governance to guidance or guidelines to regulation, right? So again, depending on the country you're from, right? So EU is obviously very active in Europe, and others are following that suit in terms of the data and the regulation around that. Now, as we all know, in US, it is sort of less so, right? So in terms of just having a comprehensive regulation. So again, different agencies are stepping in to provide various guidelines and interpreting guidelines. But at the same time, I think we should be putting, I would say, a couple of things there in terms of just the businesses doing things that because it's the right thing to do. I know there's a lot of focus around ESG, right? So going beyond the financial metrics into obviously the environmental things and also social. When we talk about social, we typically talk about diversity, equity, and inclusion, which obviously is a big part of it. But I think companies should declare, should also be incented on what part of my data am I making open, right? So is there a metric? Is that something that I can share? What of what I'm doing, I'm able to share with the broader group with the right controls. We're not saying that make every data which is proprietary, where companies make money, into open data, but there are some things that can still be made available in sensitive areas, right? So where sharing makes sense, right? So for example, in the cyber arena, why should everyone keep the cyber intrusion data private? Mainly because they don't want to expose their loopholes. Now, making some of that data available, again, within the control to some organization would allow for better solutions to emerge. Other area would be climate, of course, things that are happening. I would say maybe health is another area where that's something that we think is sort of fundamental right, is to be healthy, right? So to provide the healthcare, especially in a country like US, where it's sort of largely driven by the private, can organizations make some of that data, population level data, available under the similar kinds of controls that that Sinan was talking about, right? So making it open, then, so that's more from a business side. And I think there's also a larger community movement, crowdsourcing side of it, right? So people talk about democratization of AI, democratization of data. And I think there is this sort of democratization that I was talking earlier in terms of open data, open models, where organizations, and some of them are impact funds, so not-for-profit funds that are being funded by the VC money, to make sure that we have these data sets which are curated, validated, right? So quality checked, so that it becomes more useful rather than just open data for the sake of open data, to open data that is really useful. As Professor was saying earlier, right? So having that mobility data, right? So as to where people are moving under different kinds of government interventions, right? So during the pandemic period was immensely valuable to look at, hey, where and how the disease is spreading. How do you control? What are the interventions that work? What are the interventions that don't work? And we don't know that, right? So we have to try it out. We have to experiment, right? So we need the data to be able to make that informed decision. So I would add to what the professor was saying, right? So in addition to the regulatory approach, the innovation approach, using blockchain, using data exchanges, right? So data cooperatives, there's a whole series of things. Cooperatives are where a smaller group, it's like a mutual insurance company, right? So it's a mutual data company where people who benefit from the data, share the data, but it is within that small group of, or whatever, it may be a large group, but within that group of mutual data holders, if you like, on a specific topic, to a mutual exchange, data exchange, where people can exchange data, and I can give my personal data to a company for a specific purpose, for a specific duration, and I expect some compensation back from that data, right? So again, facilitating those transactions, right? So again, the government should step in to set the structure, but not necessarily play in the whole area, just as the financial regulations, right? So set the guardrails, but then banks are private, right? So where someone with money sort of puts in the thing. So similarly, there should be data banks, and the regulation comes from the governments, but the operation is done at a business level, at an individual level, or a not-for-profit level, right? So I think there's a lot to be done there in terms of just bringing the different pieces together, so we really can exploit this large data.
Yeah, that's great. And I want to come back on the democratization of AI, because that is something that we do see happening a lot in businesses, and that could be interesting to explore. Just before that, Sinan, I know that probably you have to leave quite soon. I did want to ask a little bit more around the kind of behavioral spillovers, which I thought was really interesting. And I suppose my question is that you can kind of have positive behavioral spillovers, and you can kind of have negative behavioral spillovers, right? So you got a positive one around the vaccine news, that was great, but we've also seen, as you say, false news spreading very quickly. We've seen it in presidential elections, arguably here in the UK, in the vote around Brexit. So the question is, how do you have a sort of view on what makes a kind of a good kind of snowball effect in terms of behavioral spillovers and generating positive attitudes, versus what sort of leads perhaps to either the spread of negative news or leads to a kind of a narrowing of the sort of political debate, that kind of polarization. I mean, what kind of conditions do you need to have in place to get the kind of the positive behavioral spillover? So I don't know if you've got sort of views on that. So I think you're just on mute. Yeah.
Definitely. So first of all, think about it this way. Human beings are herd animals. We are affected by the opinions and behaviors of our peers, and we change our opinions and behaviors based on the opinions and behaviors of our peers. So these experiments proving this out go back decades and decades and decades to the Ash experiments, where Confederates would say one line is shorter than another in an experiment, and then the respondent would change their opinion based on what the other people were saying. Other Ash experiments where people would walk down the street and there'd be a group of experimenters looking up at a building, you know, like this, and everybody would sit and look, even though there's nothing to look at. We know that human beings are herd animals, but what we've experienced in the last 2 decades is an unprecedented rewiring of our central nervous system, the onset of hyper-global connectivity in terms of information. So just think about it this way. In 2005, 2006, okay, there was no large-scale Facebook. There was no Twitter. There was no LinkedIn, TikTok. There was no Instagram. There was no WhatsApp. Now, these platforms are how we get the majority of our information across the globe. There are nearly 4 billion Facebook users on the planet. In some countries, Facebook is the internet. It is the entire access to the internet in the Philippines and parts of Africa. And so almost overnight, in human terms, we connected each other to each other in ways that we've never experienced before. And it's much, much bigger than the telephone or a one-way communication system like the television. This is many-to-many algorithmically determined information flows. We've never seen anything like it. Now, good and bad can ebb and flow through this network and also guided by the algorithms. And so, yes, there are lots of positive spillovers, and we can imagine encouraging those. And there are lots of negative spillovers, and we can imagine trying to discourage those. When it comes to misinformation, what our research shows is that that there's evidence for what we call a novelty hypothesis. So if you read the cognitive science literature, you know that human attention is drawn to novelty, things that are new or surprising in the information environment. And if you read the sociology literature, you know that we gain in status when we share novel information because we're seen as being, quote unquote, in the know or having access to inside information that our friends don't have. So it makes us seem higher status. And so this leads to the spread of falsity moving faster than the truth. And when we look at reactions to true and false news, we're actually 70% more likely to retweet false news than we are true news in our Twitter study. And when you look at reactions to true and false news, you find that false news, people react to false news with surprise and shock and disgust. Things that are blood-boiling, anger-inducing, shocking, that's what gets the most attention and gets retweeted, and that's much more likely to be false than true. And so there are behaviorals in the way that Anand noted, socio-technical systems that tend towards certain outcomes, like the spread of falsity, that can be disrupted by algorithm design, by changes in training data, by behavioral nudges. So we've done a number of experiments at the MIT IDE, led by my colleague Dave Rand at MIT, that show, for example, that behavioral nudges towards accuracy, just getting people to think about accuracy, not telling them what's true or false, but just getting them to think about the accuracy of what they're reading, statistically significantly reduces the belief in and the spreading of misinformation. So every 20th post, if it's a post that says, how accurate was that last article you read, in your opinion, then it gets the user to start thinking, maybe I should be thinking about how accurate what I'm reading is. Just that little nudge every 20th post statistically significantly reduces their belief in and spreading of misinformation. So little nudges, behavioral nudges, can go a long way. We also need much more comprehensive digital literacy, for example, for our kids to learn how to spot misinformation. What are the telltale signs? How to not fall prey to it. When you're emotionally triggered, for example, is a good sign that you might be skeptical of what you're reading. And also polarization, okay? A lot of this has to do with the design of the algorithms combined with the design of the business models. And I wrote a book called The Hype Machine, which is all about how social media disrupts our world and how we can adapt to it to realize the promise of the algorithmically driven information age and to avoid the peril. And a lot of the recommendations in that book go into much greater detail around literacy, around regulation, around competition, around how do we deal with fake news, around how do we derail the polarization and extremism that we see in various platforms.
Thank you very much. So Anand, I wanted to return to the question of the democratization of AI. And one of the trends that we see, particularly in technology companies at the moment, is this idea that everyone can kind of use AI. Everyone can sort of create their own low-code solution. And I just wonder what your kind of thoughts are on that. Do you see that as, on the whole, a good development? What are some of the challenges it might create?
Yeah, no, it's a interesting question, Mark. I've written a couple of articles around the democratization of AI. And my own personal view here is democratization per se is not bad. It's not wrong, but I think doing that more blindly without some of the education that goes around that, and also I would also add governance that goes with it, and control are key, right? So what I mean by that is when we say, oh, anyone can build a model, look here, so we have democratized the platform, click a button here, you've got ingested the data, click a button, look, there are 100 models that have been produced. Now, that level of democratization with someone going and saying, I don't know what this p-value is, right? So, but I know I need to get this lower or get this higher, and just spewing out models without really understanding, that's what I think we should really guard against. And there's a tendency to do that, right? So yeah, we have the compute power, we have all the algorithms coded here, and let's just do that. So I think that's where I think it's good that we can percolate this to a broader group of people, but that should be associated with the right education. What do these values really mean? What is the algorithm doing? Not saying that you necessarily need to know all the details of the math and the coding and so on, but you should be able to interpret the input and the output and some sense as to how that output was arrived at before you are, quote unquote, allowed to use these models in a larger sense. That's just one part of it. But then organizationally, yes, we do a lot of things around sort of democratizing the data. We have a whole citizens-led program, but it should be bounded by the governance, right? So for example, I'll give you an example as the way we work within PwC. We have a platform, a digital platform where people can submit various pieces of automation, various algorithms or models that can make not just their life easier, but their colleagues' lives easier as well, right? So it is a citizen-led program, so you can submit. Now, we don't put, so it's, if you can think of it, it's like a PwC open source models and automations. Now, we don't just put everything on the platform. We have a group that curates it. So you submit it to the group, and the group then checks it, validates it, and then puts it up in our digital platform. Then we also have the platform essentially looks at, hey, how many people are actually using it? There's a leaderboard. And so we incentivize people for writing more, as well as incentivize people for the usage. So if your bot has been used more often than others, right? So then you go up on the leaderboard. And then not only go up on the leaderboard, we actually incentivize people, right? So we give dollar amounts for if you are the top, your bot has been used the most, right? So that way, it's not free for all. And in some cases, we might say, no, this is already handled by this other model or AI program. So you need that curation so that you don't get every arbitrary junk into this. And then now we have a bigger mess here with everything being democratized and free for all. So I think governance becomes very important as you start democratizing. Education is one, but governance is the other. And then you should be able to control, especially in an enterprise environment. So one thing is to have something, if you like, in an open source academic environment for people to play around. But in the case of companies, obviously you are liable, right? So if doesn't matter what the education level or competency of the people, if you have put something that is being used by a client or used for a client project, then or by a consumer, then you are liable from a company perspective. So you need to have control around that, right? So we say that these things, as long as the democratization is being viewed with these additional areas, then I think it is fine. Just don't blindly follow democratization and say, hey, we've got the tool now, anyone can use it. That gets very tricky.
Yeah.
Especially some of the AutoML tools and so on. You need to really understand what it is.
I guess, you know, there's probably a kind of historical analogy with democratizing political institutions, that you had to have increases in education at the same time to support that. And I think we see something kind of similar around the democratization of AI. So we're almost out of time. I did want to just squeeze in one sort of final question, Anand, if I may. You talked in your opening statement, you talked about how COVID, you know, in some ways it kind of did change the game around big data and AI, because we saw all of these applications, this kind of multi-layer applications. Yep. My question is, what do you think we're going to retain from that over the next few years? I mean, obviously we'll sort of gradually move out of the kind of the crisis sort of mode, and people will probably at some stage begin to forget a little bit about COVID. But you know, what are the habits, the learnings around AI and big data that you think are going to stick and are going to kind of change our approach over the next few years? So if you have any kind of thoughts on that, that would be really great.
I think a couple of the things that I mentioned, I think will stick. One of them is, I think we've been working around this notion of simulation modeling, right? So agent-based models or system dynamic models. So basically, it is not just the data. Of course, we have machine learning, deep learning models that use historical data. And as we all know, deep learning doesn't use any domain knowledge, right? So it just sort of works off the data to make whatever classifications or predictions into the future. Now, I think what really came to the fore is being able to understand the domain, right? So like the epidemiological domain, right? So like the economy, and build causal models, right? So, and we call that more model-based AI as opposed to data-driven AI. So where we as humanity, as experts in various areas do have the domain knowledge, they can be validated or invalidated by additional data, but combining the data with the model-based approach, I think would be much better. And again, people call it a hybrid reasoning. So use the best of the deep learning approaches, but don't give up on the data that has already been semantically aggregated and used, right? So that hybrid approach, I think, will move further in my view. And related to that is also this notion of scenario analysis, being able to explore multiple future scenarios and then be able to reason in that, right? So whether you're using the sort of the counterfactuals and the work by Judea Pearl and the group around causality and counterfactuals and the what if, asking the what ifs, or you're using more system dynamics agent-based modeling, which sort of looks into the future based around certain causal loops, I think that would gain more prominence. And we are already seeing that various words. I mean, digital twin is something that people are talking about, digital twins of assets, but we're also interested in digital twin, not just of physical assets, but also of people, right? So understanding the behavior, as Sinan was saying earlier, right? So understanding that, I think that is very likely to stay with us, right? So, and there's a lot of investment going into those kinds of digital twin simulation intelligence areas. The third thing that I would hope that sort of continues on is this sort of sharing of data, sharing or more making some of these things more openly available, I should say. It's not really sharing for a profit for dollars, it is making it available free, accessibility that is made available free. And I know some of the journals have done that for COVID-19 specific publications, and maybe there are certain areas related to health or well-being in a broader sense globally that we should all agree makes sense to be more open, right? So again, I know everyone, obviously we can survive by making profits, so that's the private enterprise and the capitalism, but maybe there are areas where we can designate as something that is of common good, right? So for the entire planet, that we start making more open as well as curated set of data. I would put climate data within that, right? So I would put diversity, inclusion, equity, diversity, inclusion data within that. I would put health data within that, right? So there are very specific areas which we all can agree that there are of common good. While companies play in it, we want that data to be more available. And then I would start looking at how can academics, maybe professional associations all work together to make sure that that data is curated, not from a top-down perspective. That's where I feel crowdsourcing, open sourcing of academics, of individuals could play a big role in making sure that we have a curated set of data, curated by experts, curated by the community, sort of a community-held data, sort of data exchange, data co-op kind of approach emerging. So I think all of those things, I think in that order, I think would stay, and we should probably make attempts to have that as a sort of the foundation as we learn from this pandemic moving forward. There are things that we can take away as good lessons that will benefit everyone.
Anand, thank you so much. Really interesting. I think we could talk about this topic probably all day, but we do have to draw it to a close. It was such a rich discussion. I wouldn't even try to summarize it, but I think some of the takeaways for me around the kind of the multi-layered experiments that we had with big data and AI during the COVID epidemic. I mean, a natural experiment in some ways. So it's very interesting to see how that has played out, to hear what might stick in the longer term. Really interested in the whole idea of the behavioral spillovers from data and from social media data, and how we might have positive or negative spillovers depending on how we deal with that. And then, I think there was quite a strong theme around the sharing of data, and how do we get more open data? How do we change the incentives to share data? particularly in certain domains in health and education and the environment. So an awful lot of food for thought there. Anand, want to thank you so much. Also, Sinan, I think we had some fantastic insights today. Really great discussion, and do let us know if any of our audience want to kind of follow up with sort of additional questions. But thanks, it was really interesting.
Thank you. Yeah, enjoyed the discussion. Thanks for having me, Mark.
Thanks very much, Anand. Take care.
Thank you. Bye-bye.